going to look at some alternative ideas. Same question, sketch that parabola, x squared plus 8x plus 12. If I was to use completing the square, for instance, so there's x squared plus 8x plus 12. Completing the square, remember that's what half the coefficient of x is the key. So half the coefficient of 8 is 4, so I know it'll factorise to be x plus 4 all squared. But if I was to expand that out, I don't get 12, I get 16. So I've got to subtract 4. That format is when we looked at shifting curves. So from there, I can read off that and get the vertex straight away. I know the vertex is -4, -4, because we've shifted the x and we've shifted the y as well. Now, to find the x-intercepts, well, seeing I've already now got it in the completing the square form, I can go, oh, well, hang on, that means x plus 4 all squared is 4. So x plus 4 is either plus or minus 2. And we get our minus 6 or minus 2. If I had to write down the quadratic with roots 2 and 8, vertex 5, 3. Well, this time the key is I know the vertex is 5, 3. So if I was to put that in completing the square form, I'd go, well, x minus 5 all squared plus 3. Notice though, the constant is only times the x minus 5 all squared. Okay? We know the constant has to be plus 3. Because we're told that it's been shifted up 3. So I don't include that with the constant. So be careful with that. But I know the roots are 2 and 8. It doesn't matter which one I sub in. Which one? What do you reckon? I reckon I used 8. Because it would have given me a positive number. Let's see. Ah, yes, 2. There you go. As I say, it doesn't matter. Because 2 minus 5 is negative 3. Square it, you get 9. So 9k is equal to 3. So there's our answer that we got before of k is negative 1/3. So there's our equation in that completing the square form. If I was to expand the whole thing out, you'll see we do get the same answer as before. That's the completing the square idea. I don't know whether you will have seen this idea before or not. You might have heard of the discriminant, but what I'm going to use it for. The discriminant is basically that bit under the square root sign in the quadratic formula. And it's called the discriminant because it discriminates the solutions. Because you can't find the square root of a negative number. So if the discriminant is negative, we know we haven't got solutions. If it's positive, we know we've got solutions. Things like that. But the vertex always turns out to be minus the discriminant on 4a. Now that's useful if you've got one of those questions which says, what's the maximum or the minimum? And you don't actually want to go and find the axis of symmetry. I can find that y value without finding the axis of symmetry using this idea. And as I say, it comes from the zeros being plus or minus the square root of the discriminant. Okay. So if it's less than 0, I know the curve's going to have no x-intercepts, no solutions. If it's equal to 0, I must be talking about a parabola that's just going to touch the x-axis. And if it's greater than 0, it must be one that has 2 x-intercepts, so it'll cut through the x-axis. Alright, let's go back to this x squared plus 8x plus 12. If I work out the discriminant, for this one it turns out to be 16. So the vertex, okay, axis of symmetry, minus b on 2a, yes, I get minus 8 on 2. The y value, minus 16 on 4, and sure enough there's our answer, minus 4, minus 4.